Okay, so we're going to talk about angle projectiles, and the key thing that is going to be different with an angle projectile is that it has a velocity, it has an initial velocity in both the x and the y direction. So in the previous section with horizontal projectiles, we only had initial x velocity, and now we have an initial x and y velocity. So the first thing you have to do with an angle projectile is you have to break up that initial velocity into an x and a y component. So if you have a velocity that is, 20 meters per second at an angle of like 20 degrees, you have to break it up into a Vx naught and a Vy naught, because that's what your equations have. Your equations have an x naught value and a y naught value. There's no v naught value. And once v naught is broken up, you no longer use it. So once v naught is broken up, you only use the Vx naught and Vy naught. Like once you break up that 20, you're never going to use it again. You're going to only use its component values in the equations. So let's go ahead and just try an example of an angle projectile. So here is our question. It says a golf ball is hit off a tee with an initial velocity of 30 meters per second at an angle of 35 degrees to the horizontal. What is the range? And then what is the maximum height reach? So the first thing we have to do is to break up that velocity into an x and a y component. And so here is our velocity of 30 meters per second at an angle of 35 degrees. So we're going to use just SOHCAHTOA, actually just SO and KA, to figure out what is Vx naught and what is Vy naught. And so by now we've done enough SOHCAHTOA that we should know that for the Vx naught, we're going to use the cosine. So it's going to be 30 cosine of 35, and Vy naught is going to be 30 sine of 35. So I'll let you take a moment and calculate out what those values are. Okay, and so we should have gotten that our x naught value was, what is it, 24.57. And then our y value is, so is it 17.207? These are meters per second. So before we can actually do anything else in the problem, we had to figure out what the initial x and y values were. Now we can focus in on what it's asking. So the first part is what is the range? And range is figuring out what is delta x. Well, we only have one equation for delta x. It's Vx naught times t. And we have the x naught value, but we have to find what the t value is. So in order to find the t value, we're going to go ahead and figure out what our use our y equations for the t value. So I'm going to just kind of slide this over, and hopefully that is enough room to be able to do the problem over here. Looking at my y values, I know that my Vy naught is 17.207 meters per second. What I also know that is if this golf ball goes from here back to here, when it hits the ground, its final y velocity is just going to be negative 17.207 meters per second, okay, because of that symmetry there. So I know my initial value and I know my final value, and so I could use that first equation, that Vy is equal to Vy naught plus Ayt, and I could figure out what my time is, because I know my Vy is negative 17.207. I know that my y naught value is 17.207. My acceleration is negative 9.8, and I can solve for my t. And do not mistakenly think, oh, I've got 17.207. I've got 17.207. These are just going to cancel each other out. They do not cancel each other out. When you subtract this over, do you see how you're going to get like a negative 34 point blah, blah, blah value? So go ahead and solve for what that t value is, and we'll see what your answer is. Okay, so your t value should have been 3.512 seconds. So if that is your time, we can come back here to our delta x equation, and we can say that our delta x is going to be our Vx naught. So it's going to be our 24.57 times our time of 3.512. And that should give us a range, or a delta x value of 86.28 meters. That's our range. And then the second question asks, what is the maximum height reached? So maximum height, what do we know about maximum height from the previous chapter? It's only going up to this certain point. It's only going to take half the time to get there. So if our total time is 3.512, then that means our t up is just going to be half of that. So we could use that time value. Another thing we could use is that we know at the very tippy top, what is the y velocity? It's 0. So at the tippy top, the y velocity is 0, and that actually might be an easier equation to use. If our vy at our top is 0, and we know that vy squared equals vy naught squared plus 2a delta y. And if this term is 0 at the tippy top, then my equation is going to simplify. So 0 is going to be equal to vy naught squared, so 17.207 squared plus 2 times negative 9.8. I'm running out of room. Times delta y. So go ahead and solve for delta y. Let's see what you get. And you should have gotten a delta y of 15.017. Oh, 15.107. Okay. And we will definitely do more examples of this in class.